think we're joining from all over the country. Antoine, where are you now? You're at home or?
In a beautiful Zwolle.
Zwolle.
Oh, it's nice.
Niels?
Up north in Drenthe.
Kijk, Drenthe. Luc?
Somewhere around Deventer.
Deventer. Oh, we're really east-oriented today. Yeah. Wouter is in Den Bosch. We are in adjoining booth. So Wouter is 1 meter away, actually.
We're neighbors.
We're neighbors, but nobody can see. No. So, well, I think it's 12:02. We're going to go ahead and give it a start. Great that everybody's joining us today. Big welcome for all of you. We're having this webinar as a part 2 of the Agentic coding experiment. So maybe some of you already joined us earlier this year. I think it was the 1st of July or 2nd of July that we already discussed some of our findings. And today we're going to do a deep dive. Wouter is joining us. He's was leading the jury of this experiment. So he has a lot to say about his findings, and we're really curious about that. So first of all, let me shortly introduce all the speakers. Wouter, as I already said, is a software operations manager and also the senior talent manager at Team Rockstars. Niels, who was one of the participants of the experiment and also principal consultant at our company. Antoine from Zwolle as cloud engineer, Luc, who is AI engineer and architect, and me, I'm gonna be the host today, so I'm gonna do some moderation. If you have any questions, please make sure to use the chat. We really want to make sure that this webinar is a joint effort from all of us. So in the last few webinars, we have seen a lot of questions, and it really helps increase the quality of this session. So there are no dumb questions. Please make sure that everything you want to know, you want to give it a go and share it with us in the chat. If there are too many questions, we will answer them later after this webinar, and otherwise we will make sure to get back to the speakers. If you have a specific question for one of the guys, please make sure that you mention their name in the question. So for just a quick just to take you with us in why we did this experiment, we have a lot of speculation in our sector at this moment about what is the AI movement is going to mean for our software engineering, for our IT future. And we know there are a lot of benchmarks and specifically also evals done. Also, the labs are increasingly spending their time to give us new, better models. And we really want to know if we do a full agentic experience, full agentic development, how far can we go? Not only the shiny demos and the simple apps we see all the time, the to-do apps, but also what if we make a real-life application we use every day, and we compare that track to the classic engineering that we also do. What works, what doesn't, how can we find ways to learn from this? So that's the background. We do these experiments on all kinds of fields because we believe there's no such thing as know-it-all in this AI era, and we really believe that by experimenting and sharing our lessons, everybody can learn a little bit. So we also don't know it all. So if we have questions we don't know the answer to, we will be honest with you, but we will definitely share everything we have experienced so far. The setup, really short, and then I'm going to give the word to Wouter. Niels, Antoine, and Luc were so kind and brave to join this experiment because it's kind of like also an exciting thing to do, but also these guys have a really big calendar. So I want to thank you again for doing this. Niels is a cloud architect from backgrounds, no experience with building software. So let's see what he made of this experiment. Antoine had a special assignment today, or actually in the experiment, he couldn't let his data leave the European Union. So that was quite a big challenge also, and we have learned also a lot from that. Luc is also been building with AI for quite some time now, and he got to use all models and all environments. So this was the setup, and we wanted to compare. So it's not like a really closed loop laboratorium experiment, but it was more 3 tracks with a different approach, and then let's see what we can find. So the specs were fixed. Wouter and his team made quite an extensive backlog, and we had 20 human hours per person. That was the limit. There were no agentic hours limits, but we had a token budget of €1,000. So that was quite kept. And for some of them, that was more easy than for the others. So that's that. We're going to go ahead and I'm going to give the word to Wouter.
Yes, well, thank you. So I'm Wouter. As Simone already mentioned, I'm responsible for the internal applications, especially the profile tool, the new application that we're building now through Agentic AI. I started my career years ago as a software engineer, went to architect roles, and now I'm leading the software teams and also a talent manager, meaning that I'm responsible for 25 of our IT professionals. And in this experiment, I defined together with product owners and some business analysts the backlog of the application, and of course was part of the jury to look through all the results. And while I'm eager to take you through everything and what we've learned and what the results are, so I would say let's dive into it. Well, again, a quick reminder of what Simone just told with a bit more details. We have the setup. 3 engineers all independently built a variant, and there's also one team that we call that the classic team that built the application through regular software development, the way we're doing it in an agile way. It's also a good experiment to see how they are doing in reflection to the 3 engineers. And like Simone already mentioned, it's not a quick vibe coding exercise or experiment that we're doing. It's quite an extensive application that we're building. So we started with the same scope. We had a backlog, UI, UX requirements. We even had designs. It's a greenfield application built for our Azure Enterprise environment. And we started from that point of view with the 3 engineers and also with our classic team. We already made the decision for the agentic coding exceptions that they will not build on top of our Azure platform. That's too much governance, too much security, too much roles and accounts and all kinds of access that you needed. So we really focused on building those the application front and the back end for the next from greenfield onwards. Well, the classic team.
Sorry, Wouter. First question: the classic team was able to make sure that they use AI assistance for coding, right?
Yeah, so that's indeed where I was coming now. Looking at the classic team now, at the point of this presentation, the classic team created roughly 100K lines of code, and they did not write that all by themselves. They are allowed to use AI as well, but not in a full agentic way as the engineers did. So it's part of the workflow. Most of the engineers nowadays, almost all engineers have an AI way of working in their workflow, but they're using the let's call it assisted AI assisted, not full agentic. So that's how they developed. They spent roughly 1,500 hours, and the classic team is now at 50% estimated completion of the application. So again, it's not your vibe coding app that we're doing here. Well, now I guess it's time to dive into the results. I will go over the high over results, and after that, I will every engineer, so the 3 engineers that we have here, they will tell us about their journey, or how they went and what they did. But first of all, the high over results. To dive into the software metrics first, all 3 engineers delivered an application that was clickable, viewable, and working. And we measured those metrics with Sigrid. Sigrid is a tool that's a code quality tool, static code quality tool from the software improvement group. And we use those metrics in order to have some feeling about the application. Good thing to note is that the code was uploaded at the end. So we did not have any iterations in between. We used agentic coding to build the application, and after the 20 hours were finished, we uploaded everything to SIG to get a nice understanding of the software metrics. Well, the first thing that stands out is immediately the lines of code. AI is perfectly capable of creating a lot of code, well, up to 36K and 4 years of traditional effort. And it also comes with a wide variety. So there's a lot of variety within the code, but also between the same agents. There's a lot of assumptions made by the agents, variety in dependencies used. So they basically went all over the place. And that's something that we also think is really something that stood out. And the last thing that we thought about the metrics was something that we thought was about the production. So now we have some application that's really workable. It's a clickable demo. It's not production ready yet. And it means that there's a lot of testing still need to be done, and there's a lot of consistency to be fixed. AI makes assumptions, especially when Agentic 2 coding is used in a lot of hours, so like 10, 12-hour sessions. There's a lot of assumptions, and you see that in the end results as well.
Quick question, Wouter. I think Michael wants to know, what was the estimation of the classic team that they gave upfront for completion of the application? I think it was approximately 3,000 hours, you think?
Yeah, we thought so, but as an agile way, we approach it agile. So we didn't really make a waterfall estimation upfront. We started creating, and now we can make a better assumption that we are roughly 50%. So I think around 3,000 hours indeed. Yeah.
And Willem wants to know how the traditional effort is measured. I'm not really sure, Willem, if you mean measured by hours, or so maybe you can elaborate on that a little bit. I think we have two more questions. Gwen's question, we're going to park for a minute. We're going to come back to that later. Joost wants to know what the test to code ratio test coverage ratio is. Sorry. You can elaborate on that a bit. Yeah. Yeah.
Let me elaborate a bit more on the numbers in my slide. First of all, and I will come to the text to code ratio. First of all, those numbers about maintainability and security, the market average is around 3.5. So you really see that the AI did quite well. And that's also what we get up about the architecture and everything around the metrics. It's quite up to the market average. Then back to the test code ratio. That's not test coverage. It's the ratio between how many lines of code and how many lines of test code we have. So if you have 100% test to code ratio, you have the same amount of code as you have the same amount of test code.
Yeah, and I think I read Gwen's question a little bit better. The question is, I think, for Niels, Antoine, and Luc, if there's did we build a central agentic framework? No, we didn't. So everybody had to start from scratch.
Yeah, and that's, well, already a bit spoiler alert, but that's something that also with the lessons learned.
Then we have one final question for Justin, and then we're going to go ahead into the next part. If it's not test production ready and not tested, how is it determined that the applications are all complete? Well, Wouter, they are not, right?
No, they are complete in a way that we can open them, they can be locally run, and we can click through them. But they're we call them demo ready and not production ready. I hope that answered the questions a bit.
And Willem also explained his question. Now I understand, sorry for the misinterpretation. The traditional effort of 10 months to 4 years, how is that measured? But it's something software improvement group is gonna, it has some benchmarks on, right? Yeah.
So I'm not sure how it's measured. It's the metrics that the software improvement group provides us.
And we can already see for our own AI-assisted coding experience that we have a higher ratio also of lines of code per hour than this benchmark, right, Wouter?
Yeah. Cool. Then, any more questions, or shall I jump to the?
Yeah, there's one question, but I think the guys are going to answer it. It's about what tools and agents we will use. Antoine already answered it. Yeah. And thanks, guys, for asking so many questions. It's really nice. Go ahead with that.
Keep them coming.
Yeah.
I will answer them. Well, looking, of course, metrics are fine, but also we are building an application. So looking through it from an end user's perspective, the functional results. Well, the core product was there, and that was something that really stood out for me, and I was really fond of it. We had, of course, an IDE and a backlog that we want to build an application that we call the profile tool. So we'll manage your resumes as an engineer. And all three of the engineers, or basically all three of the agentic codes, were able to capture that core essence of the application. And within that, looking at all the kind of functionalities and the features that we were requesting, roughly about 40 to 75% of the features were present, and also really correlates to the number of lines of code. So the engineer, in this case, Luke, who has the most lines of code, also has the most functionality. And between those three engineers and between the three applications, we saw a difference in approach, also a difference in the end results. So, for example, with Niels, there were many features present, but we were missing some coverage and some gaps. There were stuff still missing. Antoine, were really budget constraints. And that he will probably elaborate on that as well. With everything hosted in the European Union. And of course, Luke, as already mentioned, most of them were present. But the cool thing was, and that for me at least, it was the AI was able to capture the core presence and the core functionality of the application. Well, before we dive into the lessons learned, I think it's really cool to hear about the journey of our engineers. So I will hand it over to Niels.
Thank you, Wouter. Niels Emmer. I'm a cloud platform architect, engineer, working in DevOps, cloud platform infrastructure for over 30 years. So I started in the on-premise world, moved to data centers, and recently everything has been in the cloud. I am not a developer, as Simona mentioned already, so I was less nervous for this entire competition than maybe other participants, because I have no beef in the game. But it was a gigantic learning experience. So I'll tell you, maybe we can just quickly skip to the next slide, Wouter. Tell you about my agentic journey. Few jobs ago, I do a lot of projects for our enterprise customers. A few jobs ago, well, like everybody else, I think I got into generative AI through ChatGPT and cloud and Gemini and all those things. And I found out that this interactive chatting with AIs really made me like times by 2 in speed and maybe times by 5 in the access to relevant knowledge I had. So that was nice, but then working with the agents and hallucinations and etc., that was basically in the hobby phase. So then there was a phase where the project I was working was using Devin, a cloud-based AI, and this agent suddenly started solving our linear tickets and our GitHub tickets, etc. That was really nice, and that made me jump into my VS Code environment, the coding thing where I always define my platform, my architectures, etc. And I installed Codex plugin, and I installed Claude Code plugin, etc., etc. And I started using my agents. And then Simona, when I was walking on the floors in Davos in our headquarters, Simona asked me, "Hey Niels, do you want to join in?" So I always say yes to everything. So I said yes. And then I saw the backlog that the jury, the very extensive and properly worked out backlog. There was a wiki, there was lots of information. And I also saw that I only had 20 hours to build. And the problem I run into with my VS Code coding agents is either I'm waiting for the agent to its work, or the agent is waiting for me if I've walked off and it needs more input from me. So I thought I need more agents. The budget seemed reasonable. So I need to jump into orchestration, which is daunting, was daunting for me because I've been seeing that on YouTube a lot, but I had no idea. So I found the open code framework for myself, and I started using YouTube and listening to podcasts and asking my agents, my chat agents, which is I've never really forgotten about, for how do you do this? How do you set this up? So my approach as an architect, as an engineer, was like structure. So I first focused on the what. What do we need to build? By having Claude build a scraper that liberated all the epics from Azure DevOps. And I had other agents compile all the wiki articles and some of the screenshots. Well, you've seen the sample, not 100% successful, but into specs. So that's the what to build. Then I watched some YouTube videos on developing, because I have no idea. I'm not a developer. I also don't know what a lead developer does. So I asked, what makes up a development team, which is the who. And all of these agents, they got their optimal models and their prompts and their skills, etc. And I was just iterative. I just asked the agent, like, can we do this? Can we do this? Then you have the what and the who, and then it's the how, because a team of individuals doesn't automatically become working together. So I needed to define workflow. So again, YouTube, how do developers test? When do you audit, etc., etc. Then I put the whole team together, and then I gave it the jury criteria. There's a few knockout criteria and scoring, like what am I scored on? And I gave the agents the mission, like I want to win. So optimize the team. Did that a number of times until the moment which I dreaded, was to start the experiment, to give the go. So I was at home, so I thought, let me wait until I'm in the office. Next day I was at headquarters and I had the audience I wanted. So I had a prompt, a starting prompt I had to give that also the agents told me about. And I gave it a go and it started working. And it was really nice to see for once that it went throughout the entire circle that I dictated. So we all looked at it and I said, look at how wonderful. And we went for coffee. And as soon as I came back from coffee, I was half expecting the thing to ask me a question, but it was still working. And I was amazed at the speed that it was working. And then I looked at what it was actually doing, and it was just writing epic number 7. And I thought, I know agents are quick, but you can't build 7 epics in the time I have a cup of coffee and test and document and audit everything. So I stopped the process and I asked him, what are you doing? And the AI, as it always does, it said, I'm so sorry, I should have done this and this. What do we do now? So we had a lot of tech debt when I asked it to go back to epic number 2 and test everything and audit everything. So yeah, that was an extra session in which we had to clean all the tech debt and I had to tell it what was important and what was not important, because otherwise epic 3 and 4 and 5 and 6 would just compound all the wrong directions that were taken. So that's my struggle looked away. The orchestrator, I thought I'd prepared it. I'd given it so much test. I'd given it a few one-shotters, like build me a to-do app, make no mistakes. And it actually followed the entire workflow, but not when it mattered. So I had to step in, and what I thought would be 1 session, in the end turned out to be 5 sessions or something. What
Niels,
I would do different. Sorry?
Sorry, one question about your struggle. Marcel asks, didn't you start over again instead of fixing the tech debt? What did you do actually? Did you start
Yeah, good question. I told it to go back to where it should have started the entire cycle of validation, security testing, documentation, etc. And it noted deviations from the invariants and everything and the ADR that I had defined the proper architecture. So that collected a bunch of tech debt. And then the AI presented me with, do you want to solve this? Do we start again? And I thought it's manageable. And I just asked it to get rid of all the tech debt, which easily took as much time as it took it to write the first 7 epics. I hope that answers the question. Yeah. I see the comment. What I would do differently this time, yeah, there's 3 examples that would have helped me in this first coding experiment. I'm sure that I will, that the message is next time I'll learn from the lessons from this first experiment. But I also know that next time Anthropic or Alibaba or whoever will have changed their models. So there'll be different learning moments during a follow-up phase. What surprised me the most, positively, because again, I'm not a developer, is that something came out of it that worked. And that Wouter, who knows code, and the SIG group who know code didn't say, ha ha ha, this is horrible, this is awful, I can see you're not a developer. So that something workable was produced was a big surprise for me. And what I first thought negative, but actually for me it's very positive, surprise is that I feel like the coming 2, 3, 4 years, the human will be needed in the loop. So I'm not worried about my job. That was basically my little journey.
You're fine. Thanks, Niels. I have one follow-up question from Willem. He says, well, it sounds like you try to recreate more like a classic engineering team that is used now in software development by humans. But it doesn't necessarily mean that it's also the best way to build a team with AI. Have you thought about doing it another way, or would it be something you would do in the future?
I learned indeed that there's many different ways, and we replicate what we know. So indeed, that was the classical engineering team. I also got very valid feedback, like what you're doing is basically waterfall. It's not very agile because you're starting from this point and you focus everything on it. So yes, I would say let us try 3 different ways of doing it and compare those.
Yeah. Thanks so much. All right, I think we're going to go to Antoine.
Yes. So I'm Antoine Tielbeke. Like I said, I live in the beautiful Zwolle here. I'm a cloud engineer for I think around 5, 6 years now. I mostly work on sovereign clouds at Nexus currently, and my whole work, daily life, outside of life, kind of looks like EU only European products, preference for European products. So this constraint was more of my daily work and daily life than really a constraint in that regard. And even at work, it's a preference. It's a very present preference. And so for agentic coding, I use it mostly on the daily, on my job as an infrastructure, everything. Not really coding, so to say, more of all the infrastructure things. So my reflections, because I learned a lot from this one. Like I said, the constraint was European only, like European jurisdiction. So my confusing thing here was I used EU only jurisdiction tools or infrastructure like that. Like open code is, let's say, American, but it's open source. So I used open code as my harness. I used open models and mostly open weight models. These are Chinese models, so Kimi, GLM, whatever. They're Chinese model, but they never go to a Chinese API, to a Chinese server, never. They were only offered by European providers. And here was actually kind of a thing, because you also have European providers like Amazon that have a data center in Europe, but the jurisdiction is not Europe. So I really only use TensorX, Nebius, like these data centers that are really located in the EU. And for that, I had an European AI gateway router. I used EU router. Again, I wouldn't choose them again this time, because I will tell you later why. And I use different models for different things. So for my approach is like many of the open source model at that time didn't have a vision model, but Kimi did have a vision model. So I had this thing where if I was designing something, I would use Kimi, but if I was doing something simpler, I was using DeepSeek Pro or whatever. My struggles along the way were that when I started, many of the AI is subsidized. So you're just building, oh, I hit my limit, whatever, I'll continue in a few hours. I told it, hey, make an .NET Postgres project scaffold. And this scaffold, I told them search for some best practices, already cost me 25 euros, I think. I was like, oof, this is going to be painful. So immediately I wanted to do the same as the others, like make a spec of all the tickets. But I was like, okay, probably reading this whole backlog, turning into a spec, finding contradictions is going to cost me so many tokens. What my idea is going to be, and after it wasn't the best idea, but at that time I thought I'm going to do like the Claude Opus way. At that time when Opus was the best, is I just throw a really good model at it and it will figure it out on the fly. Which is one time Anthropic told in a presentation and I was like, I'm going to do that. And it wasn't the greatest experience. I will come back to that question later. So the struggle was that I didn't have the spec, and after that really bit me. And my gateway did not have caching. So every request I did sent the whole context back and forth. So for the budget thing, I ran out of budget quite quickly, and I didn't really build the most features because I went through the budget so quickly because the whole code was being sent back and forth, and that cost me so much money. And I did some calculations with AI, and it's the whole input-output token with caching would have saved me like 60% of my costs. Maybe before I go to point 3, I can answer the questions that I see in the chat. Is that all right, Simona?
Yes, of course. First one, wouldn't you be able to use AWS Bedrock? Anthropic
Because
models
AWS Bedrock is still an American company, so you're still completely liable. You still have the dependency. It's kind of like we're gonna try our best efforts. It's really easy if you're already on AWS. You can just say, hey, it's an EU data center, but it's still American jurisdiction, so you're not really solving any problem there. You're just kind of hoping it passes the audit, and it's not really a real change for that. But the good part about that is when you use Bedrock, you actually pay per input-output token. So you get a more real price of what you're using instead of a subsidized subscription model. So I do think that's a good part.
Yeah, but
the second question,
it's still the Cloud Act, your jurisdiction is under. Yeah,
you're still under the Cloud Act, the 4 Eyes, everything.
Yeah.
The second one, Mistral codes. I really tried to use Mistral. And if you've used Mistral, it feels like you're using the old GPT. I'm going to be sorry, Mistral. I really like you. But Mistral code just kept writing readmes so many times. It's the really old thing, like stop writing readme and just did it again. I tried it. It's for basic coding, like for your home assistant, your smart home automation, it's fine. But more than that, it's not really my thing.
At this moment, we will say, right? Because
at this moment,
yeah.
Because they're offering GLM 5.2 soon. So I also see the comments for the GLM 5.3 Flash. Yes, at that time, I think when I started, just Kimi 2.6, 2.7 came out. So they were really like in the getting better phase. And now with all these new models, I'm sure I would have done maybe better, I would say so. And with all the caching, it also would have been probably easier. So I really agree with you there. I don't have the space heaters like you have. I think that would be nice in the coming winter. So my next point, what would I do differently? Yes, I would do the spec development, which is just way better. I made a workflow throughout the project. I made 2 skills. One skill that read the epic, built the context for the epic. So when I was building a feature in that epic, it didn't have to reread the whole code base. It could just reference with another skill that's written markdown the context of that epic. So for one whole epic, the whole context written down and didn't have to fetch it every time. I would use a gateway with caching. If I can choose again, I would choose Cortex.ai. It's my favorite one now. They're amazing. I love them. They don't have a subscription model like EU Router, and they just have pay per token, which is lovely. And they have really good cost data insights. What surprised me the most is that infrastructure mattered a lot in this challenge. Not really the models, not really the things. I think this day and age with harnesses, good local compression when you need it, good caching, like all those things around it matter more. I'm not saying go install all those 100 tools that your colleagues recommend, but just having a good local setup is really the more bottleneck for me than the whole infrastructure and model. You can do all of these cool things in Europe, I think, these days without having Claude or Codex or all these things. And for me, the caching was really the bottleneck more than the model. That was mine.
Thanks so much, Antoine. I see a comment from Rick that Scaleway added prompt caching to the DeepSeek model. So I think you already know about that probably because you follow everything from Scaleway. But yeah,
I have emailed them a lot about this, and this is one of my feature requests to them too. So yes, I'm really happy for new models they're adding it.
Thanks so much, Antoine. We're going to go ahead and listen to Luc.
Yeah, thank you. I'm Luc Honshorst. I'm an AI architect, solution architect at Team Rockstars. Working 17 years now. Full stack, but also CI/CD infrastructure as code, etc. I have the nice opportunity to work already 2.5 years with AI daily at my current assignment. both agentic development as the engineering part. So building software relying on AI. Yeah, I can. Next slide. Yeah, my approach, because I work already a lot with those kind of tooling, I know that AI could build valid code. So that was not really a question for me. I was very curious, how far can I push this system to say, okay, we have specs and just go to build. And it could take many days, no problem at all. Just validate the specs and go to build. So my approach was the same as the others, using the APIs to get all the user stories, specs, etc. Also some additional information on the wiki, and most of the half of the time was preparing that information. So constantly running open code with some plugin to validate, okay, are the specs clear? Are there open questions? And in that, let's say it's a system, I called it the spec builder for this experiment, was a part where I say, okay, if you have questions and you can make yourself a decision, mark it as AI decision in a separate file, and that's good. If it's really has, I don't know for sure what to do, then it would ask it to me. So after some iterations, I get a lot of questions about this and that, etc. What was not clear for my spec builder, how to solve it. So that was the manual input I needed to give it to the system. About the system itself, I use OpenCode with all my Open Agents plugin. The strong thing about this is that it automatically switches between models. So for example, when we had an UI UX task, it says, okay, I know that Gemini is a strong model to do this kind of task. So it automatically solved that. It was not me that I need to kind of drop down and select another model. The system itself does this. The same for architecture and actually coding part. There's some kind of presets depending on the model provider that you plug in, that it knows which model to use, all automatic. So that one I used for the spec builder. At the end, I had a lot of spec files created in the format of spec kit, specification-driven development, and an agents.md where I made the technical decisions. Sorry, the system made the technical decisions with some input about you should use Angular and that kind of stuff. So that was the way I worked. Specs, based on spec kit for the functionality, and agents.md for the architectural governance. Yeah, the struggles all the way. I think the first part was that the amount of specs were that much that my system was keep looping and sometimes keep asking the same questions about decision that needs to make. So that was a bit hard. At the end, it solved it, but that took more time than I expected. And also some trust issues with the system. Because I say, okay, create a lot of tests, etc. I think that I had more tests and better tests, I thought, than normal on projects. But everything was in green, so a very good test. But when I opened the application, it didn't work, or it didn't work as expected. So in this particular case, the end-to-end tests were based on the deep links, and that way the system was right. But when you open the application and want to use it as a user, you want to navigate through a menu. That menu wasn't there at all. But the test, we're using the deep links because it knows the system, and everything was green. So in the basic, it was a good application, but it was not working at all. So that was a bit of struggle. What would I do differently the next time? I think for me it was a big part about it has created a lot of code, so that's nice. But for me, the feeling about okay, what is it even building? This amount of code, I don't have any clue anymore about, is it even production ready? What has it built? Do I see even everything what it has built, or are there hidden features, etc.? So for the experiment, I think that was cool. But in the end, for production software, I need more confirmation along the way to have feeling about the software itself. So what surprised me the most, I think, that context part. I thought with big context windows that we have solved that issue. But when you have a lot of specs, then it's still a problem. Also, for me, the pricing part was a bit hard. First of all, I thought €1,000, that's quite enough. But from the 1st of June, I think, my model provider, Git Copilot, increased heavily the prices, and sometimes a factor of 10. So what I normally use in a day, I use in 1 hour encoding. So the pricing perspective is a really new insight that I need to use when I will do this experiment again. So pricing is a much more a topic at the moment than it was before. So that's also for me an issue. Also in that thing in mind, the efficiency of all my open code is maybe not altered the good one, because it supports a lot of models and it had a lot of prompting, automatic prompting, where the prompt also supports other models, and that gives a kind of overhead, and that was not a problem, but now on the pricing part it is a problem. So I would look at a more streamlined version specific on the cost part. I
Thanks
think
so much,
that's it for me.
Yeah, thanks so much. Very clear. We have one remark/question where one of the participants of the webinar says, beyond a certain complexity threshold, agents start losing track sometimes of what is already implemented unless it's explicitly mentioned in the spec. So therefore, there's a risk to that there's duplication, complexity. Agents also sometimes have a tendency to solve problems with more code than necessary. Do you guys, I think the question is for all three of you, tips on how to prevent this? I know we also wrote a white paper was coming next week with some points on that, but maybe you can elaborate on that for a quick moment.
I would say that you're saying indeed open spec, which are good specs. They can be closed, remarks can be done. But I think the best thing is some people make like one really gigantic agents file. You can use Headroom, Serena, Open Knowledge Format, all these tools, but they build like a local markdown knowledge base with index files. And when your agent is working on, let's say, identity, it goes to an index file. It says, oh, we have identity, and then there's an index file. So it only loads the knowledge it needs of that path. And then you just make a skill in your project that forces developers to have always this documentation up to date. And you have like this automated, very efficient knowledge base for your LLM. That's my preferred method.
Anything to add, Niels or Luc? I think it's clear, but I don't know if you have any additions, because otherwise we're going to go to Wouter because he has some concluding slides.
I have an addition. What I see and believe in is that sometimes you first have the spec and you want to build the software and just go ahead with building that stuff. And then later on, you can spin up another agent specific on, okay, the specs are working, but can I optimize the code? Maybe less code or faster code, etc. And another agent, for example, on the security part. What I see, that's very hard to, let's say, one shot, have all those items marked and solved properly. So more in an iterative way of a multi-agent setup. But again, then you also had a lot of costs to manage. So that's the downside of it.
Thanks so much, Luc. Yeah. Hope we solved your question. And then we're going to go ahead to Wouter for some concluding remarks.
We'll dive into the conclusions and the lessons learned. As Simone already mentioned, there will be a white paper coming out. So all those deep dives and details will be in there. I'll just tell you the main conclusions. So first of all, quality. Demo is not a product. So what we saw is that the code that was produced, and the AI is perfectly capable nowadays of creating a lot of code, the solid code, but it's not the product yet. And looking at what makes it the product, well, it's all kinds of robustness, completeness, but the most important thing there is engineering trust. The engineers didn't have the trust or the ownership or feel comfortable to take ownership to get that application into production. And that's something that, because AI creates that much code, it's really hard to get that ownership or that trust. And that was, for me, the main gap in order to get it into production, for example. Well, the next conclusion is speed. And we already mentioned this a couple of times. AI is perfectly capable of creating a lot of code. In case from Niels, like 9 epics in 1 cup of coffee. So it's building a lot in a short time. It's getting a demo working really quickly. And that's, I would say, as a product manager, that's awesome. I had sprint demos where I requested something, and by the end of the sprint demo, it is already in production. It's super cool to see those kind of things happening. But at the end, speed also requires control. Means smaller increments, clear requirements, and a lot of testing and reviewing. And well, especially with the clear requirements, I know from experience, it's quite hard for humans to write requirements that are clear and also, well, in a way that we all understand. Well, staying at the conclusion 2, speed. What we really see, and it's basically the feeling that we have during this experiment, that the AI shifts effort. So with traditional classic development, you see that requirement, planning, design, implement, test, and accept all takes, well, let's say roughly the same amount of time. And there's always some time in between to really think about what you're doing, how you're doing it, why you're doing it. And with AI, we really see that the AI shifts those efforts. So there's a lot of time spent and needed to get those requirements clear and up and running. And then, well, the plan, the design, and the implement, well, basically you just say fire and forget, and it will take care of that in an hour or 8 or 10. And it's there. But that means that there's so much created after that the test and acceptance phase takes a lot of more time. And especially when doing, well, experiment like this, where we basically had the test and acceptance phase at the end, is so much that is for an end user, a stakeholder like me, really hard to test and to give feedback on, because it's so much is created and there's so much assumptions there, and assumptions that are also different because the AI make different decisions, and it's really hard to accept or test an application that's huge and that large. So yeah, it really needs speed. It's really nice with AI, but it needs more control. Well, the third conclusion, development in the loop, and that means quality in the loop, meaning that within your agent workflow, quality needs to be there. So make sure that the code quality is there, but also in the loop, acceptance criteria. Make sure that every after development cycle, check the acceptance criteria, check your functional tests, basically click through the application yourself, or maybe ask the AI at the end of development loop, give me a plan of approach of how I should test your work. Guide those agents to standards for maintainability, complexity, and testing, and everything around that. And also connect your agent to code quality assurance. We did it at the end, but you can also do that in the development loop, that it will, after creating code, it will check with the quality assurance tooling, is this something, what's your feedback? And it will automatically also, well, work on those feedback to get the quality up and running in the development loop. So basically include the quality in your loop. And also within that development loop, make sure there's a human. That's something that I think also the conclusion from Luc was, it goes just so much work. It's really hard to well, basically see what's doing. But also with traditional development, you create a feature and then you think about it, you test it, and maybe go another direction because it's not working yet. And AI goes so fast that those decision points are not there anymore. So AI takes on the production work, it will create stuff, it will build routines, it will troubleshoot, it will create everything, but the human needs to be in the loop. It will need to set the scope, acceptance criteria, it will test it, it will need to own the quality, security, and the risks. That's for the end user, so stakeholders, product owners, product managers, but also for the engineer. It needs to understand the code and basically get a feeling with it to know what's wrong. Because now with the demos, when I ask a question, how is this working? The engineer does not know and cannot pinpoint where the error is. And that's something that with the human in the loop is really necessary. I just continue and interrupt me if there are questions, by the way. But
yeah, there are questions, Wouter, but we'll take them after your conclusion, I think. But we have already 3 questions waiting for after the conclusion. Yeah.
Next, and I will just continue. This is the last conclusion, and that's standardization. And I think that question was almost answered in the first 5 minutes or something of this presentation. One of in the audience indeed asked, did they all need to develop their own scaffolding and their own agent framework? Yeah, they did. That's also a conclusion. That's something you don't need to reinvent for every project every time. You can build a foundation as an organization. What models, what agents are we going to use? What coding standards? How can we centralize it to make sure that every engineer can use our agent scaffolding or our agent army in that way to make sure that those agents work with a quality level that we as a company really want to, and also put it in a place where the engineers can use it. So think about, okay, now we have 1 or maybe 10 engineers using it, but what if the whole organization is using it? So really think about it scaling up. You can build it yourself. You can use open source tooling like that. One really important thing with standardization is find a level, and I don't have the answer yet, on what are we going to basically tell the engineers to use and how they have to use it, and what is the wiggle room that they have, domain specific, project specific stuff that they can add or change. And I think nowadays engineers have their own flavor of working, their own AI that they want to use. So there needs to be some kind of flexibility, but also I think it takes a lot of time to build this, so we need to standardize it. So, in summary.
Thanks so much. Yeah. You're going to do the summary maybe, and then afterwards we're going to close with some questions. Yeah.
Yeah, let's do that. Okay.
Yeah. Please be quick because the questions are coming in.
Yeah. Okay. I'll go. Well, four things. AI enables speed. So we've seen that a demo is not yet a product, and small increments with the human in the loop, those are just necessary to get that feeling, to get the cognitive load going on, capable of just knowing what the AI is doing. And last, organize the basics centrally. So make sure that the scaffolding, the whole AI workflow, not every project or every developer needs to reinvent that themselves. So before we dive into the questions, if you need to take one last quote from this presentation, and then I will end with that. AI builds fast, but people define the scope and make sure it delivers value.
Thanks so much, guys. Thanks so much, Wouter. We have 6 minutes for maybe 5 questions. So we're going to go and check what we can answer. Maybe some of the questions already have had some form of answer. First one, I think really important that we also elaborate a little bit on in the white paper, but how to solve the ownership questions, how can we tackle the trust we have in the code that agents produce? Who can share something about this?
I can say that it's something I fully recognize, because not only do I not know what's good code and bad code, really, from my background, but also, indeed, what you're saying, when something breaks, where is it? And the only thing I found to mitigate that slightly is to have dialogues with the agent, to ask the agent, because it's documented everything during building, why choices were made or why a certain direction has been picked. So I asked the agent to explain its choices.
Thanks, Niels. And I think also, Luc, one of your recommendations is to make shorter iterations, right? To make sure that you have quicker stops. Can you say something about that?
Yeah, I think that's mainly that two parts. The official one, somebody in the company should have take ownership. So that's depending on the company. Is that a reviewer? Is that the original coder, etc.? Even when I build everything with AI, still I am the owner. So that is the, let's say, the more the legal perspective of that one. For me, it's more indeed about the shorter iterations. So that way I have more ownership. I can do multiple demos, etc. Maybe a 2 weekly demo. Every 2 weeks, and demo is not enough. But something inside that way, that would be enough for me to have building the software with AI, but still have that feeling of, okay, I'm owning this software. But it's more up to the team and the person itself, what they need to have that feeling.
Thanks. Yeah. I'm going to go give it a little bit speed. The conclusion, would you say, guys, that the classic and AI route would be approximately take the same amount of time? Is there something you can, maybe Wouter, you can share on that? We can't say it for sure, I know, but can you make your best guess?
Well, I think that it all depends on the scale of the application, because we see now that the application that we're trying to build it's quite extensive, and we do it from greenfield, from scratch. So it's now, I think it will roughly take the same amount indeed, because we just so much going on and so much to understand after the AI is complete. And basically, well, I think there's a lot of work in getting those last nitty-gritty details of the AI working. And with AI, we're with the classic team, we're at 50% now, but the 50% that we have is production ready, and I feel comfortable with the stuff that we have. So I think, roughly for now, my suggestion would be get a classic team, let them work with AI as much as possible, but in a classic way. That will be my approach for now.
For this moment, but we can see the signs that it's changing quite fast. And if we would do this again, we probably would have a lot better result also. Okay, last few questions. There's a cognitive load question. Are we see agentic coding affecting our cognitive load? But also, I think a flow question, skill degradation is going to be a thing. We think so. We've written quite a bit about that in our AI and work white paper, and also in Engineer the Future. Also in this white paper, I think cognitive load will be one of our big themes for the next 3 to 5 years. So we do a lot of things, including coaching and all kind of efforts to make sure that we can manage this load. And we think it's really necessary to do more deep dives on that. So I'm going to make some speed by answering this question myself. Last question. I'm going to give it a quick look. How to tackle I see a question of Willem. Newer models will behave differently than older models, where human software engineer is more likely to improve overall and not to make new mistakes that used to go right. How can we tackle this going forward? Getting control and trust over the AI models when there's new models coming out with different flaws and perks?
I would love to respond to this one. I think if you have a good AI team with a centralized AI gateway where they model the behavior of the inputs and outputs, but also they provide teams with good harnessing, good tools, good skills, like they really give their teams the tools that they can perform their best without spending every minute of their time in AI. I think just having that strong AI team will kind of negate that problem.
Thanks so much, Antoine.
There's a question that I would like to answer, if that's okay for you, Simona.
Yeah.
There's about saying, did the experiment succeed or not with 30 Ks of lines, but only working demo? I would say the experiment definitely succeeded because we learned a lot, and that was our goal. But looking at from a project manager side of perspective, I don't believe in first time right. And what we did right now was basically a first time right. We just asked them, they went 20 hours away somewhere in the water, and then they popped up again, and then they showed me the demo. And I don't believe in that. So I'm absolutely sure that if we do the experiment again, and then we'll have regular check-ins, regular demos, and we also give the AI the opportunity to correct itself after feedback I gave the AI or gave the engineer, then probably went up with a result that's usable. But it was first time right now, and that's why I don't think it's still on working demo level.
That was the design of the experiment, and indeed, when we would do that differently next time, we will probably see a lot better results. So I want to thank you all very much, because a lot of you have follow-up meetings. If you could go to the last slide, Wouter, for me. Thanks so much for your participation, for all the questions. And I think we will be really glad to share all the lessons we learned in the white paper next week. We will send you as a follow-up. And definitely we'll make sure that we keep experimenting. I hope you will join us in these experiments. And I hope you will have a good day, good Friday, and we'll see you soon. Thank you so much.
Bye-bye.
Bye-bye.